Hello, today in class we're going to solve another equation where we'll use the algorithm and the product property. And squared. A minus 4 times A equals 0. You and I have already used the properties when solving the equation. Let's remember these properties. If one of the multipliers in an equation is 0, then the whole product is 0. But in our equation, we don't see a product. We see the summand, but the difference of these two expressions is 0. We don't know how to solve quadratic equations yet. And then these quadratic equations can be solved in a different way. What do we do to do that? When solving an equation, we use the method of decomposition into multipliers, and we've talked about this method. What do? Well, we need to decompose the left-hand side into multipliers. There are several techniques for doing that, and one of these techniques is putting the common multiplier behind the brackets. Recall when we converted algebraic expressions, we also used the method of putting the common multiplier behind the parenthesis. For example, if I write down the following expression, 3a minus 3b. That's an algebraic expression. That's not an equation. That's an expression I can write in a different form. It's a sum. I can write it down as a product. In that case, I can see the common factor, which is 3. And I can put the 3 out of the bracket. Then a minus b remains in the bracket. So I've decomposed this into two multipliers. That's the method I'm going to use in our equation, but in our equation we don't see the common factor written as a number. We see letter expressions, but the thing is that letter expressions can also be decomposed into multipliers. What do we need to do in this case? Let's write the first summand of an a squared as a product. In this case, I'm going to write a squared as a multiplied by a minus 4. There is no sign between the number 4 and a. Then the rules say that this sign multiply equals 0. What do we see? In this, we see a common multiplier equal to a. And then we can take that multiplier out of the parenthesis too. And then what's left in the parenthesis? A is taken away. That leaves a. Minus 4 equals 0. And this is the kind of equation we know how to solve. And we'll remember our properties. The product equals 0. Only if one of the multipliers is 0. And let's remember that we broke such equations into two parts. And then I can write that a equals 0. Or a minus 4 equals 0. And then a will equal 4. Notice that we got two roots in this equation. The first root equals 0 and the second root equals 4. So I can write down that a first equals 0 and a second equals 4. Very often you ask, does the first equal 0 and the second equals 4? No, you can write a first equals 4 and a second equals 0. Either way, we get two solutions, two roots, and if we substitute 0 into our original equality, then we have an equality. Let's check it out. Instead of a, I'm going to substitute the first value, which is 0. A squared 0 squared minus 4 times 0 must equal 0. Let's see, 0 squared is 0, minus 4 times 0 is 0, and we see that 0 equals 0. That's a valid equation. And so, therefore, the root of a equal to 0 is the root of our equation. Let's substitute the number 4. Instead of a, we'll substitute 4. The result is 4 squared minus 4 times 4 must equal 0. And we see with you that 4 squared is 16, and 4 times 4 is also 16. And 16 minus 16 is 0. So we have a correct numerical equality. If you see an equation in math that can be decomposed into multipliers in such a way that the product is 0, then we can apply the multiplication property where the product is 0. In the next lesson, we will solve another equation. Today our lesson has come to an end. Goodbye. See you again.